doubts you can ask. Okay, we'll conduct one class.
First class, second August को జరిగింది కదా సార్.
Second.
Sir, first can you tell maths Ioqm syllabus, sir? We don't. Sir, could you
Yes, sir.
Sir, can you
Okay,
say
Anna, okay. Okay, I'll explain syllabus also. Okay.
Sir, when the first class has done, sir? 1st August to 2nd August, sir.
First class Tuesday onwards we have started.
Sir,
First onwards only. This is third class.
Sir, what is the topic?
Can you tell me syllabus, sir?
Sir, that
Number 3, syllabus is number 3. Next, geometry. Combinatrix. Combinatrix is nothing but permutations and combinations. Mute yourself.
After geometry.
sir, can you send the
Number 3, plane geometry, combinatrix. Okay. See, you can buy books.
What is the topic? Question paper,
Can
sir.
you say somewhat clearly, sir? The voice is. What book you are teaching? What's the name of the book you are teaching?
Raju Manoj
What is the
Pathfinder.
Please,
What book you are teaching, sir?
Lakshmikant sir, please raise your hand and turn on your video. Ramana sir, please give him the co-host, sir.
I received co-host.
Yeah, okay, good. Lakshmikant sir,
Yes,
meanwhile,
start,
just
sir.
want to say the course syllabus, exam syllabus.
Okay.
Majority of the students, they are asking about the syllabus of the Ioqm, no?
Yes,
Just
sir.
once before starting the lesson, you write the list of the topics so that the students, they will take the screenshots. And very good advice to all the students. If you require any particular problem, you just take it as a screenshot. Afterwards, you can just note down on a book. Good model some sir is teaching you, utilize this opportunity and giving the time for the noting down purpose means it takes a lot of time. So time is also major important factor here. So I request all the students, you please take the screenshots which particular problem you require. So it is better to note down all the problems, because sir is teaching not only the particular problems but also previously given Ioqm questions also sir is teaching while he is teaching. So utilize this opportunity. So Krishna Lakshmikant sir, you before going to start, once please write the topic names so that students will take the screenshots, sir. Okay.
Yes, sir.
Thank you. Now it is 8 o'clock. You can start the class. Thank you.
Okay, thank you. Okay. So good evening, everyone. So welcome to all to the math class session 3. So in this session, so we are going to learn about LCM and HCF related problems and division algorithm related problems. So as all you requested me to teach the Olympiad syllabus. See, the main Olympiad syllabus for Ioqm exam is number theory. See, we are going to learn about now this number 3 now. So number 3 is main topic. See, and the questions will come from geometry also. Okay. And so combinatorics. So these are the major part. So most of the questions we'll get from these 3 chapters, and we also get algebra. So in algebra, so we get questions from theory of equations. Okay, like quadratic equations. Mostly we'll get from theory of equations only. Mainly cubic equation, fourth degree equation there. And in sequence and series also we'll get some questions. So in sequence and series, mainly we have to focus on the telescopic method. So, or you can say VN method. So this is one syllabus. And when it comes to algebra part, so functions also they will ask. So functions and some functional equations related, and few arithmetic sums also they were asking. So arithmetic is related. So like time and work. Okay, there are very few questions from this part. So time and work. Okay, time, distance. So these are the related these sums they are going to ask. And inequalities also they are going to ask. So inequalities they are asking. So this is the major syllabus, but 1 or 2 questions may come from other portions also. So sometimes they will ask trigonometry also, but very less. So trigonometric questions very less. Sometimes they may ask 1 or 2 questions. And geometry. So in this geometry, so related to properties of triangles. Properties of triangles also they can ask some questions related to properties of triangles are also they are asking. So the main important syllabus for Ioqm is number 3 is the main topic, and combinatorics. So permutations and combinations. So these are the, and geometry also. So in algebra they are asking from theory of equations. So 1 or 2 questions from sequence and series, and functions also very less, but these 3 major questions we are getting from this, and algebra also we are getting. So this is the overall syllabus for an idea. So and see, for this Ioqm generally we don't have any like specific book, but we usually follow Olympiad book. So we follow Rajiv Manocha and Pathfinder. So Rajiv Manocha and Pathfinder. So these are the 2 main books we follow. So we have lot of books for Olympiad, but so what we do here is according to the syllabus, we are going to look at the previous question papers and similar model questions we are going to search and we are going to teach. So that is how we have to prepare for the Olympiad examination. Okay, so I hope this is clear. So now see, yesterday we have solved few problems from LCM and HCF related problems. Now this LCM and HCF related concepts are very important in Ioqm. So let us solve one more problem to understand much better. So, and now I am going to teach one more problem based on LCM and HCF, and I am going to teach related to division algorithm problems. See now, this is the question now which we are going to solve this. See, this question is asked in AMC 10 2018. So AMC is nothing but American Mathematical Contest. So in the year of 2018, they have asked this question. So we have already learnt in the previous class, whenever they have given 2 numbers, we need to consider. So A they have given A is equal to dx. So B is another number, dy we should consider, and LCM we should consider. So LCM of A and B, how? dxy. We have already learned in this previous class. And HCF, or you can take GCD. So GCD, how can we write? So GCD of these two numbers, we can write it as D. So using this, we have to solve the given problem. And look at here, AB plus 63. How many ordered pairs A comma B of positive integers satisfy the equation? So now AB, what is A here? We can take dx, and B is nothing but dy plus 63 is equal to 20 times LCM of A comma B. What is LCM? dxy, 20 dxy plus 12 times GCD of A comma B. So what we are going to take? So we are going to take 12D. Now look at here, D times D. So this we can write it as the D times dxy. So D times dxy plus 63 minus 20 dxy minus 12D is equal to 0. See, the thing what we should do here is we have to convert this into product of two expressions or two factors we have to convert. So here we have one problem. Now dxy here, how many? Three variables are there. See, let us replace dxy is equal to t. So let us replace some variable dxy is equal to t. See, let us replace dxy is equal to some other variable t. So now what will happen? This equation becomes dt plus 63 minus 20t minus 12d is equal to 0. So here the most important point here is A is equal to dx, B is equal to dy. X and y are what? X and y are natural numbers. They are multiples, right? So A is a dx, B is equal to dy. X and y are natural numbers. So from this we can clearly say that dxy is equal to t. So definitely t is greater than d. So definitely t is greater than d. Okay. So now we need to factorize this. See, look at here. Take from common from these two terms. What I can take? I can take t common, t into d minus 20. See, while we are factorizing, remaining two terms are there here. What are they? Minus 12d plus 63 is equal to 0. So whenever we factorize, what we do generally, the same term should come again. Here. So 63 minus 12d. Okay, let us take d common so that we'll get e. So you take d common from this. So when you take d common, what do you get? T minus 12. So what is remaining here? Minus 20t plus 63. So is equal to 0. Okay. So now we need to factorize this. So how can we factorize here? Okay. So here dt plus 63. So dt minus 20t. So let me write here dt minus 20t. So and here minus 12d. So let me check once. So AB dxy. So this is 63, 20 into dxy minus 12d. So we are replacing dxy is equal to t. So we are replacing dxy is equal to t, and dt plus 63 minus 12d. So minus 20t. So is equal to 0. So let us take t common. So when we take t common, we'll get d minus 20. So let us take t common here. So let us take t common. See, we are going to get d minus 20. So what is remaining terms here? So we are getting 12d plus 63 is equal to 0. See, while we are factorizing, d minus 20 factor again we should get here also. Then only we can able to factorize. So to do that, what we do here is t into d minus 20. So first I am going to write here d minus 20 here. So in order to get d minus 20, what I should write here? So we have to take minus 12 common. So minus 12 times what is this? D minus 20, right? So minus 12 times d, minus into minus plus 240. So we have to subtract, that is minus 240. See, now it will be clear, right? So minus 12 times d minus 12d plus 240 minus 240. So we'll get cancelled, plus 63 is equal to 0. So this is how we can write. So now what we do the next step? So now let us simplify this. So now you can take d minus 20 common here. So d minus 20 we can take common. So when you take d minus 20 common, so what is remaining term here? T minus 12. Let us send this 240, right answer, 240 minus 63. So what is 240 minus 63? So d minus 20 times t minus 12 is equal to, so is it 177? 177 plus 3, 180 plus 62. Now this one we have to solve. Look at here, this is a product of two factors, d minus 20 times t minus 12, and it is 177. See, 7 plus 7, 14 plus 1, so it is divisible by 3. So 3 times 59 we can write, or we can write 1 into 177. So now we have to write the different cases. So here what we have already taken one condition. What is that? T should be greater than d. T should be greater than d. So what are the possibilities for d minus 20? T should be greater than t. So you can take, see, for example, let me write all the possibilities, 177 and 1 and 177. So 3 and 59. So 59 and 3. So these are the possibilities. But we have replaced t is equal to dxy. T should be greater than d. T should be greater than d. So now here t value, maximum value you should take. So we can take this value. We can take this value. So this is not possible. This is not possible. Why? Because t is greater than d. So now two cases will arise. So hope it is clear for everyone. So now let us consider the first case. So what is the first case? So t minus 12 is equal to, so case 1 we are going to take. So case 1 is equal to t minus 12 is equal to 177. Okay. And d minus 20 is equal to 1. So what is t value? Now t is nothing but 189. Now what about d value? D is nothing but 120. Now we have already taken, right? T is equal to what? dxy. Dxy is equal to 189. We got d value. So let us put here. So what we are going to get here? So 21 xy is equal to 189. So 21 xy is equal to 189 means what is xy value? So xy is equal to 9. Xy is equal to 189 by 21. This value is 9. So we have already learned yesterday onwards. I keep on telling x and y must be co-primes. Very, very important point. X and y are co-primes. Co-primes. See how many ways you can divide here. X you can take 1, y is equal to 9. Right? This is one possibility. Or x is equal to 9, y is equal to 1. These are the two possibilities you will get. Now we have already taken, right? So what are the values we have taken here? A is equal to dx, b is equal to dy. So a is equal to dx, b is equal to dy. So we already got d value here. D value is what? 21. So if you take x is equal to 1, if we take x is equal to 1, y is equal to 9, a is equal to 21, b is equal to 21 into 9, 189. If we take x is equal to 9, a is equal to dx, a is equal to 189, and b is equal to dy. So what is this value now? B is equal to 20. Now here we got two pairs we got. What are they? 189 comma 21 and 21 comma 180. And we have another case also. So what is that case? So we have to consider here 3 and 59. 3 and 59. So what is 3 value here? D minus 20 is 3, because we have 4 possibilities will get among those. So we have to take only these two. Why? Because T is greater than D. Now this case we are going to consider case 2. So in case 2, D minus 20 is 3. D minus 20 is 3. And T minus 12 is equal to 59. T minus. Now D minus 20 is equal to 2 means what is this value? D is equal to 23. So what about T? T is equal to 59 plus 12, 70. But T is nothing but what? Dxy. Dxy is equal to 71. D23, right? 23xy is equal to 71. See, now xy is equal to 20, xy is equal to 71 by 23, which is not possible. So which is not possible. Why? Because x and y are natural numbers, right? See, we have written a is equal to dx, b is equal to dy, right? So this is not possible. Now totally how many ordered pairs will get? We get only 2 ordered pairs. What are they? 189 comma 189 comma 21 and 21 comma 181. So 2 ordered pairs will get. 2 ordered pairs only will get. See here in the problem they mentioned a comma b. That is the reason answer is 2. A comma b. So a comma b, because a is equal to 189 and b is equal to 21 is different. A is equal to 21 and b is equal to 189 are different. So 2 answers. In the problem, if they do not mention, so number of ordered pairs, if they mention, then the answer will be 1 only. So I hope it is clear for everyone. So now we are going to solve problems on division algorithm. So division algorithm. So just I am going to explain just basic understanding of division algorithm, and then we'll start the problem. So division algorithm. So division algorithm means, now see, let us take any number. So let us take some number 33. So let us divide by 5. See, now 5 times 6 is equal to what? 30. So this is 3. Now how can we write here 33? See, 33 is equal to, we can write 5 into 6 plus 3. So we know that what is 5? 5 is a divisor, and so this is quotient, and 3 is a remainder. So this everyone knows, remainder, and 33 is nothing but a dividend. So dividend. So now what we can write here, see, from this we can write 33 is dividend, right? So we can write dividend is equal to divisor into quotient, plus divisor into quotient plus remainder. So this is how we'll write. So you take any number. So let us take any number. So when you divide by this, so you take a number a and you take the divisor b. So when the quotient is q and remainder is r, so how we are going to write? A is equal to bq plus r. Okay, and we already know that r ranges from 0 to b minus 1. So b minus 1. So this is the general basic division algorithm. So in this one, now we are going to solve 2 basic questions, and then we'll solve Olympiad level question. See, now just I'm going to take one example to understand. Now look at here, find the smallest number which when divided by 12, 16, 18 will leave a remainder 5 in each case. So a very simple problem. So we know how to solve, everyone knows. So smallest number which when divided by what? 12, 16 and 18. So what I am going to do here is, let the number is n. Let the number be n. Let us say capital N. See, we are divided by 12. Is 12 is a divisor. So I am going to write 12. 12 is a divisor. So n. We don't know what will be the quotient. Let us say the quotient is q1. and remainder is given. Remainder is 5 in each case. So remainder is 5. Next, what is second one? 16. When you divide by 16, the same number. So we don't know what quotient will get. Let us say Q2 and the remainder is 5. And when you divide the same number by 18, so the quotient is, let us say Q3 and the remainder is 5. And the remainder is 5. So now see, from all these cases, we can write capital N is equal to what? Divisor into quotient plus remainder. So can we write like this? 12 Q1 plus 5. So here also we can take capital N is equal to what? 16 times Q2 plus 5. And here also we can write capital N is equal to 18 Q3 plus 5. See, because when the remainder is same, it is very easy for us to solve the problem. See, now let us rewrite these equations. So which can be written as capital N minus 5 is equal to 12 times Q1. Now capital N minus 5 is equal to 16 times Q2, and capital N minus 5 is equal to 18 times Q. See, we need a common number, right? We need a common number, right? So how can you find out here N minus 5? Because N minus 5 is a multiple of 12, N minus 5 is a multiple of 16, N minus 5 is a multiple of 18. So now how can we write this? Now N minus 5 is a LCM, multiples of LCM, right? So now how can you write? You can write here N minus 5, you can write it as LCM of 12 into 12, 16 and 18. Okay, we can write multiples of this one, right? So now how can you write capital N? Now capital N is equal to, we can write LCM of 12, 16 and 18 times K plus 5. This is how we'll solve the problem. So this is how the procedure goes. Now look at here, let us find the LCM of 12, 16 and 18. So divide by 2, 2 times 6, 2 times 8, 2 times 9. And let us divide again, we can divide by 3, 3 times 2, 3 times 4. So 3 times 3. So again you can divide by 2, 2 times 1, 2 times 2. So this is 3. So 6, 12. Okay, something wrong. So 12, 16. So 2 times 6, 8 and 9. So divide by 3. So 3 times 2. So 8 and 9. So we can divide by 2. 1, 4, 3. So now what is 2 into 3? 6. 6 into 2, 12. 12 into 4. 48 into 3, 144. So we can write this one as 144K plus 5. So what is the least number we'll get here? So N is equal to 149 we'll get. So this is the least number. So when we divide by all these numbers, we'll get. So now similarly, let us solve one more problem. So let us solve one more problem to understand this. See, now look at here. See, find the smallest number which when divided by 28 and 32 leaves remainders 8 and 12 respectively. So here, see, this is slightly different from other problem there, whereas in the previous problem, all the remainders were same. But here 28 and 32, right? So what we can do here is, see, we are dividing by 28. Let us say the number is N. So we are dividing by 28 and the number is N. So quotient we don't know. Let us say Q1 and the remainder is 8. And divide the same number by 32 and we get the remainder as 12. We get the remainder as 12. So this is Q. So how can we write here? Number is equal to 28 times of Q1 plus 8. Now look at here, number is equal to, we can write here 32 times of Q2 plus 12. So here the remainders are different. So what we do here is, but when you see the differences are same here. So 28 minus 8 is 20. 32 minus 12 is equal to 20. So now what I can do here is I can add 20 on both the sides. So we can write this one, N plus 20 is equal to 28 Q1 plus 28. So N is equal to N plus 20. So we can write here N plus 20 is equal to 32 Q2 plus 32. So we can write here n plus 20. How can we write? 28 into q1 plus 1. And here you can write n plus 20 is equal to 32 times q2 plus 1. Now we can clearly say that n plus 20 is a common multiples of 28 and 32. So we can say that n plus 20 is equal to LCM of 28 and 32 into some constant k. So what is the LCM of 28 and 32? So let us find out 2 times 14, 2 times 16, 2 times 7 and 2 times 8. So they are co-primes. 2 into 2, 4. 4 into 7, 28. So 28 into 8, 64. 64. So this is 224. So we can write here n plus 20 is equal to what we will get? 224k. So what are the values of n? We can write n is equal to what? 224k minus 20. So if you put k is equal to 1, we are going to get 204 will get. So 204 is the least number. 204 is the least number, which when divided by 28 and 32, leaving the remainders 8 and 12 respectively. See, this is the kind of problems which we are going to which we solve in regular school curriculum. But when it comes to Olympiad, so here we have observed the two cases, right? So in the previous cases, the remainder is same. See, in the previous cases here, the remainder is same. Whereas in the second case, the differences are same. So when the differences are same, so difference is 20. So when we get this kind of problem, what we do? We find LCM of two numbers and we subtract 20 from it. But when it comes to the Olympiad exams, they won't ask this type of questions. They may ask in 2 marks, but very rare. But we can't expect this kind of questions. But look at this number. So find least number, which when divided by 9, 11 and 13 leaves remainders 1, 2, 3 respectively. Okay, so this is the question they are asking. So when we look at here, remainders are not same, and you can see the difference. 9 minus 1 is 8, and you see that 11 minus 2 is 9, and we can see that 13 minus 3 is 10. So all the three are different, so they are not same. So but how to solve this kind of problem? So we have different methods. We can use the congruent method, and we can also use Chinese remainder method. But we should have knowledge of congruencies, then only we are able to understand the Chinese remainder theorem. But anyway, without using those also we can solve by using a division algorithm. So we have already learned. See, n, let us take the number n. When you divide by 9, what is the remainder you are getting? 1. So let us say this is q1. And when you divide by number 11, so what is the remainder we are going to get? We get as 2. So when you take the remainder 13, so divisor 13, what is the remainder? So we are getting 3. Now see, we know how to write the common terms, right? Now capital N can be written as 9 times q1 plus 1, and from this we can write 11 times q2 plus 2. From this one we can write 13 times q3 plus 3. See, this is how we'll write. Now let us say this is equation number 1. Hope it is clear for everyone. I'm going slowly. So find the least number, which when divided by 9, 11 and 13, leaving remainders 1, 2, 3. So that number, let us consider n. So n can be written as 9 times q1 plus 1, because 1 is a remainder now. 11 times q2 plus 2, 2 is a remainder. 13 times q3 plus 3, so where 3 is the remainder. Now see, first what we do here is, we are going to find out a number which satisfies these two. First, see, we are going to find out a number which satisfies these two conditions. Later on, we are going to find out that number should satisfy this one also, like that. So first, let us take these two equations and let us solve. So we can take this one as x is equal to 9 times q1 plus 1 is equal to 11 times Q2 plus 2. So now see 9Q1, how can we write? 9Q1 is equal to what? 11Q2 plus 1. 9Q1 is equal to what? 11 times Q2 plus 1. We can write like this. Now in this step, what we do now here? So here we already know that Q1, Q2 are what? Q1, Q2 are natural numbers. Q1, Q2, Q3 are natural numbers. So I am going to write now Q1. So Q1, 9Q1, right? So 9Q1 is equal to, let me write 11Q2. I am going to write it as 9Q2 plus 2Q2 plus 1. See, now let us divide this equation by 9. What will happen when you divide by this? This is Q2 plus divide this one. What will happen? 2Q2 plus 1 by 9. So here what we do here is we have to consider one least value of Q2 in such a way that, so this should be a natural number. See, you take a Q2 is equal to 1, 2 plus 1, 3 by 9. It does not divide. See, Q2 is equal to 1 because what is this value? 2 plus 1, 3 by 9 it will come. So 3 by 9. So we don't take this. Take 2, 2 into 2, 4 plus 1. What is this? 5 by 9. We don't take this. Take Q2 is equal to 3, 2 into 3, 6 plus 1, 7 by 9. So this is also not possible. Take 4. See, 4 it will satisfy, right? 2 into 4, 8. 2 into 4, 8 plus 1, 9 by 9. So what we have to take now, you should consider Q2 as 4. Now Q2 is equal to 4. Now if Q2 is equal to 4, what about Q1 value? Q2 is equal to 4. Now Q1 can be written as 4 plus, this is 2 into 4 plus 1 by 9. So is it 4 plus 1? Now 4 plus 1 is nothing but 5, right? Now this one you substitute here in the second equation. We will get X value. So what is X value? Now X is nothing but first you find out this value. So what is this here? 9Q1 plus 1. So here now I am going to write 9Q1 plus 1. So after that I'll start here. I'm starting here. So what here, substitute here, X is equal to what? 9Q1. What is Q1? 5. So you can substitute here 9Q1 plus 1 means 9 into 5 plus 1. So 45 plus 1 what? 46. You can also replace Q2. Then also you will get 46 only. 11Q2 plus 2. So what we will get? 11 times 4 plus 2. So we'll get 46 here. So now the number, least number is the 46, which satisfies these two only. So the 46 number which satisfy these first two conditions only. But the number which should satisfy all the three conditions. So then only we get our answer, right? So now what we do here is, now X, so the common value of X you can write it as, what is here? This is multiple of 9. This is multiple of 11. Least number which satisfy is 46, right? So least number which we satisfy is 46. So now what we write here? So you should write X is equal to LCM of 9 and 11 into some constant. Let us say K4. We have, let us say Q4. So we have already taken Q1, Q2, Q3. Let us say Q4 plus 46. See, these are the numbers which satisfy first two conditions only. Now we have to check for third condition also. Then only we will get correct answer. Now what is this value? LCM of 9 and 11. 9 and 11 are co-primes. So I can write 99 Q4 plus 46. So now this one we should equate in the first equation. Let us put this in equation 1. Let us put this in equation 1. So now we should equate to that third condition and we should find out Q3 value, Q4 value. So what will happen now? So let us in equation 1, what we'll get? So what is that equation 1? So when we divide, see, when we divide by 13, we'll get 13. So 13 Q2 plus 3. So this is the third one. So now we are going to equate 13q3 plus 3, and this value we are going to equate. So let us equate now. What will happen? 13q3 plus 3 is equal to 99q4 plus 46. Okay, hope it is clear. Now we have to find out this value, q3 value. So how to find out? So now 13q3 is equal to what? 99q4 plus 46 minus 3. What is this? 43 you will get. Now this one you write it as a multiples of 13. So 13 6 is 78, 13 7 is 91. So I am going to write 13q3 is equal to, now this one we can split like this, 91 into q4 plus 8 into q4 plus 43 can be written as multiples of 39 plus 4. We can take 31 plus 4. Now this one you divide by this. So how can we write here? Now q3 is equal to, I am combining this and this. So 91 q4 plus 39 by 13 plus, what is this? 8 q4 plus 4 by 13 I am writing. So now see, now what we can write now, what is this? Is it 7q4? So 7q4 plus 3 plus this is 8q4 plus 4 by 30. Now q2. See, for what value of q4? For what value of q4? This is divisible by 13. See, look at here, 8q4 plus 4 by 13. See, you take q4 is equal to 1. What you will get? 12 by 13. This won't satisfy. q4 if you take 2, 8 into 2, 16 plus 4. So 20 by 13. This will not satisfy. q3, so it won't satisfy. 8 into 3, 24 plus 4, 28. So 8 into 5. So 40 plus 4, 44, it won't satisfy. For what value it will satisfy? So 5, 44. So q4 we can take it as 6. So what is 6 value now? 8 into 6 plus 4 by 13. 8 into 6, 48 plus 4, 52 by 13. So this is 4. So for what value of q4 will get q3 as integer? Least value, q4 must be 6. So q4 must be 6. Hope it is clear. Now you substitute in here q3. So q3 is equal to what here now? 7 into 6 plus 3 plus 8 into 6. 8 into 6 plus 4 by 13 you will get. Now what is this value? 7 into 6, 42 plus 3. So this is 45 plus this is 52 by 13, right? So this is 4. So 45 plus 4, is it 49? So we got q3 as 49. So we got q3 as 49. So now q3 as 49. Now see, you have to substitute this value in the original equation, first equation. So we can replace q3 is equal to 49 here. So hope it is clear. We have to replace q3 is equal to 49 here. Okay. So when you replace q3 is equal to 49, we will get n value. So the n values we can write it as, see that n is equal to, what is this? 13q3 plus 3. So let us substitute here 13 into 49 plus 3. So multiply here. So 49 into 13. So how much you'll get? So 49 into 13. So you multiply with 3, 7, 27. So 147, 14. So 7, 13, 637. So what is this value? 637 plus 3. So 640. So this is the least number. How to write general solution? General solution is, we are dividing by this one by 9, 11 and 13, right? So the common solution is LCM of 9, 11 and 13, 9, 11 and 13 into k plus 640. So when you put k is equal to 0, you will get least number 640, because 9, 11, 13 are divisors. So this 640 is greater than all the divisors, right? So you can put k is equal to 0. So the least number which satisfies the least number. So the least number which satisfies. So the least number which satisfies is 640 you will get. Okay. So hope it is clear. So let us verify this. So whether it is correct or not, let us verify once. Now 640 when you divide by 9. So what is the remainder we got? We should get, so 1, 2, 3, right? Remainders are 1, 2, 3. So now 9, how many? 9, 7 just 63. 9, 7 just 63, 10, 1. So remainder is 1. So 1 is a remainder, right? Next, you divide number 640 by 11. So 11 times 1, 11 times 5, 55, 90, 90 means 11, 8, 58. So remainder is 2. So remainder is 2, right? Now when you divide 640 by 13, so now divide, what will happen? 13 times 1. So 13 5s. So 13 fours. 13 fours what? 52. 120, right? So 120 means 39s. So you are going to get 3. See, we have checked now this number. Okay, hope it is clear. See, I'll come once again, I'll revise. See, the question they asked is find the least number which when divided by 9, 11 and 13. 9, 11 and 13. So which leaves the remainders 1, 2, 3 respectively. Which leaves the remainders 1, 2, 3 respectively. So now n can be written as 9q1 plus q 9q1 plus 1, 11q2 plus 2, and 13q3 plus 3. First, we are going to find out a number which satisfies these two conditions. These two conditions will find out number. How to find out? You have to express q1 in terms of q2. So we have written q1 in terms of q2. So we have expressed here q1 is equal to q2 plus 2q2 plus 1 by 9. We have to select q2. We have to select q2 in such a way that 2q2 plus 1 by 9 is a natural number. So the least possible value is 4. So now when you take q2 is equal to 4, so here you will get q1 is equal to 5. Now substitute here. So what value you will get here? 9q1 plus 1, 46. Same value we will get here also, 11q2 plus 2. Because 46 is the number, 46 is the least number which will satisfy these two conditions. Only first two. This 46 is not satisfying third one. Look at here, 46 by 9. So what is the remainder you will get? 1 you will get. Divide 46 by 11. 11. What is the remainder? You are getting 2. But when you divide 46 by 13, we don't get a remainder 3. So you can check 46 by 30. So 13 3 is 39. So remainder is not 3 here. So now what we do here is we are going to write the common numbers. How to write that common number? LCM of 9 and 11 times Q4 plus 46, least number. Now for what value of Q4, this will satisfy the condition for next one, 13Q3 plus 3. So that is the reason what we do, we have equated to that third condition. Now we have expressed the given expression Q3 in terms of Q4 in such a way that 8Q4 plus 4 by 13 is a natural number. So what is the Q4 least value? The least value which satisfies is 6. So the least value which satisfies is 6. Q4 is a 6. So least value, satisfy value is Q4 is 6. Now, so now when you substitute here, Q3 will get 49. When we substitute here, 640 will get. So 640 is the least number which satisfies these conditions. So this is one example. So this is how the questions they will ask and the questions from this. And here in last PRMO, one question they asked based on this. So actually in PRMO 2019, so In PRMO 2019, here they asked here, n is the smallest number in E. So in the original question paper, they asked the largest number. So largest number they asked. So they asked in PRMO 2019. So 2019. Actually, that question was mistake. So they gave bonus. Bonus was given. But so the general question is it should be smallest number in E. So how we can solve this problem? Look at here. E is all natural numbers n such that when divided by 11, 12, and 13 respectively, remainders in that order, arithmetic progression. So remainders in order, arithmetic progression divided by this. Okay, so here the question prime numbers should be there. So in the questions they asked remainders in order, arithmetic in progressions. So the remainders are prime numbers. So remainders are prime numbers. They gave in the question. In the question given, so remainders are prime numbers. See, what are the prime numbers which are in arithmetic progression? What are the cases possible? See, we can take 3, 5, 7. They are prime numbers. So this is case 1. See, now you can take this in reverse order. What is this? Case 2. Case 2, you can take it as 7, 5, 3. So this is also is an arithmetic progression 7, 5, 3. And case 3. And case 3 is 3, 7, and 11. So these are the only 3 cases possible when the prime numbers are in arithmetic progression. So now the differences are same. 3 plus 2, 3 plus 2, 5, 5 plus 2, 7. Now this is also arithmetic progression -2, -2. Common difference is same. So here this is +4 and this is +4. So in all the 3 cases, we have to solve the problem and we should find the smallest number. We should find the smallest number. So this is also again an easy problem. So when we have idea about congruencies, we can solve this one again in 3 ways. But here we can also use a simple division algorithm and we can solve the problem. See, by using this division algorithm, we can easily solve. So general simplification only, we don't need any extra knowledge. So we can easily solve the problem. So here now 3 cases will get. So what is that one is? Case 1. Case 1 is what? When we divide by 11, 12, 13. What are the remainders? So remainders are, you can take 3, 5, 7. Remainders are 3, 5, 7. So this is first case. And another case is when you take the divisors 11, 12, 13. What are the remainders? You can take 7, 5, 3. This is another case. And you can take case 3. So case 3 is what? When the divisors are 11, 12, 13. When the divisors are 11, 12, 13. So the remainders are 3, 7, and 11. See now how we have solved in the previous problem. Like similarly, we have to solve in 3 different cases. Now in these 3 different cases, we'll get the answer. So that is, what is the least number among these 3 cases? That is the answer actually. Okay. So now let us consider this first case. This case you consider. So let us say here case 2 here I am taking, because now n is equal to what we can write? 11 q1 plus 7 is equal to, now what is the remainder? 12 q2 plus 5, and it is equal to next one 13 q3 plus 3. See, we have written right. So when you divide a number by 11, 12, 13, so we are going to get the remainders. What are they? 7, 5, 3. Because in the question they gave prime numbers in arithmetic progressions. Okay, so the 3 possibilities are there: 3, 5, 7. One case, 7, 5, 3. Another case, 3, 7, 11. Another case, and 11, 7, 3 also will get. So, but 11, 7, 3 is not possible. So why? Because 11, 7, 3. So divisor is 11 only, right? So no need to take this. Okay. So now here 13 Q2. Now see, generally how we solved the previous problem, similarly here also we will solve. So how to solve? Let us take this one x. 11 Q1 plus 7 is equal to what? 12 Q2 plus 5. Okay. So same way, express Q1 in terms of Q2. So how can I write? 11 Q1 is equal to, we can write this one as 12 Q2 minus 2. So 12 Q2 minus 2. So you can write 11 Q1 can be written as 11 Q2 plus Q2 minus 2. So now Q1 is equal to what? Divide by 11 on both sides. What will happen? Is it Q2 plus what about this? This is Q2 minus 2 by 11. So Q2 minus 2 by 11. See here, you can take Q2 as 2 now. Very simple. See, Q2 is equal to 2 we can take. So now when you take Q2 is equal to 2, what about Q1? Q1 is equal to 2 plus 2 minus 2 by 11. So 2 plus 0. What do you get? 2. Now substitute that 2 here. Substitute that 2 here. So what will happen now? X is equal to what? 11 into 2 plus 7. So what is this? 29. Now what is another one? This one also you take. What is this? 12 times 2 plus 5. So this is also 29. Now whether this number satisfies third condition also you check once. So 13 into 2, 26 plus 3. This is satisfying third condition also. So now when x is equal to 29, now you can write this one. You can write, how can you write 29? 29 can be written as 13 times 2 plus 3. We can write. So what do we understand by this? We can say that 29 is satisfying all the three conditions, right? See, you can verify 29 when you divide by 11. What is the remainder there? 11 2 times 2, 22, 7 is the remainder. 29 divided by 12, 5 is the remainder. 29 divided by 13, 3 as a remainder. So in this case, we got 29. Okay. So this is the least number which we get here. Okay. So now let us solve other cases also. So because they are asking smallest number, they are supposed to ask the smallest number in the exam. So this was the bonus question in PRMO 2019. So they supposed to ask smallest number, but in the question they asked largest number. So now see, we have solved one case. Now let us solve for another case. So let us solve another case. See, when they ask 3, 7, 11. So when you divide number by 11, 12, 13. So remainders are 3, 7, 11. Okay. So how can we write the number? So n is equal to, you can write it as 11 times q1 plus 3 and 12 times q2 plus 7 is equal to 13 times q3 plus 11. Okay. So now you simplify this. How can we write? 11 q1 is equal to 12 q2 plus 4. Now divided by 11. So how can we write? So 11 q1 is equal to 11 q2 plus q2 plus 4 divided by 11. So you can write q1 is equal to q2 plus 4 by 11. See, what is the least value of here q2? So q2 least value, we can take it as 7. So you can take q2 value as 7. So now substitute here. q2 is equal to 7 means what is q1 value? 7 plus 4 by 11. So 7 plus 1, we will get 8. So now what is this? q1 is equal to 8, right? Now q1 is equal to 8, you can substitute here in the given equation. So let us say here these two parts, let us consider this as x. So x is equal to 11 q1 plus 3 is equal to 12 q2 plus 7. So now I can write x is equal to 11 times q1. q1 is 8 plus 3. So what you will get here? 83 plus 3. So 91. Even if you substitute in the 12 q2 plus 7. So q2 is how much? q2 is 7. 12 times 7, 84 plus 7. Still it is 91. Now, but 91 is not satisfying this. 91 by 13, remainder is not 11. So this is exactly divisible. So now what we do here is, so we need to check for next number. So how to write x values? LCM of 11 and 12 times Q4 plus 91. These are the values. What is the LCM of 11 and 12? Is it 132? So 132 Q4 plus 91, right? Now this values you should equate to this third condition, because this 91 will satisfy only first two conditions only. Now we have to take this x and we should equate to 13 Q3 plus 11. Okay, so now when we equate to that, so we are going to get, so what value we will get? Let us equate 13 Q3 plus 11 is equal to 132 Q4 plus 91. Now simplify this. 13 Q3 is equal to what we are going to get? 132 Q4 plus 91 minus 11. How much? 80 you will get. Okay. So now let us simplify this. So write this one as multiples of 13. So I can write this one, 13 Q3 is equal to 130 Q4 plus 2 Q4 plus 80 can be written as multiples of 13, right? Can we write 78 plus 2? Now simplify this. So 13 Q3 is equal to, let us write 130 Q4 plus 78 plus 2 Q4 plus 2. Now divided by 13. So what you will get here? Q3 is equal to 130 Q4 plus 78 by 13 plus 2 Q4 plus 2 by 13. Now when you divide by this, what you will get here? Q3 is equal to 10 into Q4 plus 6 plus this is 2Q4 plus 2 by 30. Now you have to find Q4 in such a way that it should be 2Q4 plus 2 is a multiple of 30. It should be a natural number. For what value it will satisfy? You can clearly say that 1, 2, 3. 30 nearest you can take 7. 7 times 2, 14 plus 2, 16. It won't get. So next multiple of 13, 26. When do you get 26? Look at here, multiple of 13 you check. 2Q4 plus 2, we won't get 13 because 13 minus 2 what? 2Q4 is equal to 11. We don't get. Next multiple you equate. 13 into 26 will get, right? 26 for what value of Q4 will get 26? 12. 12 you substitute. Now Q3 is equal to what? Q3 is equal to 10 into 12 plus 6 plus 2 into Q4. 24 plus 12, 26 by 13. So what do you get here now value? So this is 120 plus 6 plus 2. So you are going to get 128. So this 128 we should substitute here. This is n value, right? N is equal to 13 Q3 plus 11. So you can write here 13 into 128 plus 11. Okay. Now simplify this. So now when we simplify this, so multiply here now 128 into 13. So 128 into 13, 13 8 is 104, 26 plus 10, 36, 13 plus 3, 16. So you will get 1664 plus 11. So what is this value? 1675. So n is the value is how much? 1615. Still we have another cases also is there, right? So similar model we should check. So we can easily understand once you solve this problem. So 29 is the least value. So the answer should be 29. Okay, so hope it is clear for everyone. So I'll give you some homework questions. So you do those questions. So I'm going to paste here. See, note down these questions and then you practice. Okay, see, take these questions and practice few questions. See, this is also LCM HCF related questions. So asked in PRMO 2019. So that's all for today's class. Okay, so I'll give you 2 more questions based on this problem, division algorithm. So you do those sums. Okay. Okay, thank you for joining the session. So thank you everyone. Esther, we are going to end up.
Yeah, okay.
Okay.
Thank you, Lakshmikant garu. Thanks you
Thank
all
you.
for joining the class. So tomorrow sharp at 8 o'clock again we'll start the class. Thank you.
Okay, thank
Have a nice day.
లక్ష్మీకాంత్ సార్
you. Yes, sir. Yes, sir.
అది క్వశ్చన్స్ అనేవి అంటే ప్రొజెక్టర్ మీద డిస్ప్లే చేసే టైంలో వాళ్ళకి బ్యాక్ వాళ్ళకి కనబట్టలేదు అన్నట్టు వచ్చింది సార్, ఫోన్ వచ్చింది.
Okay.
అది
ఇప్పుడా సార్?
క్వశ్చన్స్ అంటే అది కాదు సత్య,
సార్
క్వశ్చన్స్ అంటే ఇప్పుడు సార్ డిస్ప్లే చేసిన క్వశ్చన్స్
కాదు 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 ఇందాక సార్ స్టార్ట్ చేసినప్పుడు ఒక క్వశ్చన్ పెట్టారు, ఒక క్వశ్చన్ చూపిస్తున్నారు కదా క్వశ్చన్,
అంటే
ఓకే.
అది డిస్ప్లే అనేది ప్రొజెక్టర్ లో లాస్ట్ లో అంటే ప్రొజెక్టర్ వేస్తున్నారు మనకి బ్రాంచెస్, లాస్ట్ లో బ్రాంచెస్
అవును.
అవి లాస్ట్
అవును.
కి స్మాల్ గా ఉన్నాయి, అసలు ఏమి కనబట్టలేదు అన్నట్టు అన్నారు. ఒక్కసారి అది చూడండి సార్.
ప్రొజెక్టర్ వేసినా సరే ఆ స్క్రీన్ ని ఎన్లార్జ్ చేసుకునే పాసిబిలిటీ ఉంటే, లేదంటే ఆ క్వశ్చన్ ముందు వాళ్ళు ఎవరైనా డిక్టేట్ చేస్తారో చేసుకోవచ్చు. ఓకే, విల్ గివ్ అన్ ఆప్షన్.
ఓకే సార్.
లక్ష్మీకాంత్ గారు క్వశ్చన్ ఇట్లా వాటిని
అది మిడిల్ లో రాస్తాం సార్, స్క్రీన్ మిడిల్ లో రాస్తే సరిపోతుంది.
దట్స్ బెటర్ అండి, దట్స్ బెటర్.
ఓకే సార్, థ్యాంక్ యూ.
ఫాంట్ సైజ్ అంటే క్వశ్చన్ రాసేటప్పుడు కొంచెం ఫాంట్ సైజ్ కూడా ట్రై టు మేక్ ఇట్ బిగ్.
ఓకే సార్, ఓకే సార్.
అంటే నార్మలీ వైల్ యు ఆర్ ఎక్స్ప్లెయినింగ్ ద సమ్ దట్స్ ఓకే, వైల్ యు ఆర్ షోయింగ్ ద క్వశ్చన్ దట్ ఇస్ ద మెయిన్ ట్రబుల్. సో బెటర్ టు రైట్ ద, ఇఫ్ క్వశ్చన్ ఇస్ a small question, better to write it on the writing pad, sir.
Okay sir, sure.
Yeah, okay. Thank you. Good night to all. Thank you.
Okay, thank you.